Welcome back. This is your quick revision for the CBSE Class 10 board. Electricity in about 10 minutes. Not the whole textbook, just the minimum you need to score. And here is what this video covers year by year. From 2022 to 2026, 97% of every electricity question that came on the CBSE Class 10 board. 2022 and 2026 were 100% covered. So if you only have 10 minutes, this is the right 10 minutes. Let's go. First, what is current? It is the rate of flow of charge. 1 ampere is 1 coulomb of charge flowing every second. In symbols, I equals Q by T. What pushes that charge is voltage, the potential difference measured in volts. Push is voltage. Flow is current. Potential difference is the energy given to each unit of charge. 1 volt is 1 joule per coulomb. The cell provides this push. V equals W by Q. Ohm's law links voltage and current. Voltage equals current times resistance. V equals IR. Resistance in ohms is the wire fighting the flow. Resistance depends on 3 things. A longer wire resists more, a thinner wire resists more, and the material, called resistivity, RO. So R equals rho L by A. Join resistors end to end in series, and resistances simply add, with the same current through each. Join them side by side in parallel, and the total drops below the smallest, with the same voltage across each. Series adds up, parallel drops down. Push current through resistance and you get heat. Joule's law, H equals I squared RT, and power, P equals VI, which is also I squared R, or V squared by R. Now lock them in. A few tricks. Say them with me. 1. The magic triangle. V on top, I and R below. Cover what you want. Cover R, and you are left with V by I. 2. On a voltage-current graph, the slope is the resistance. Steeper means stronger. 3. Resistance is rho L by A. Long and thin is high. 4. Stretch a wire and the resistance becomes 4 times because it depends on length squared. 5. Heat and power. I squared RT and P equals VI. 6. For resistors in parallel, 1 by R total equals 1 by R1 plus 1 by R2. For just 2 resistors, that is simply product by sum. 7. The unit on your electricity bill. 1 unit is 1 kilowatt hour, 1,000 watts running for 1 hour. Now pause the video, cover the screen. Can you say them from memory? That 1 act of recall is worth 10 rereads. Before the questions, here is how to actually solve any electricity problem on the board. 5 steps. The same 5 every time. Step 1. Draw the circuit, even if not asked. Mark every cell, every resistor, every ammeter, every voltmeter. Label the voltage. Label each resistance. The numbers stop being scary when they sit on a circuit. Step 2. Identify what is asked. Are you finding current I, voltage V, resistance R, power P, or heat H? Underline the unknown. Everything else feeds into it. Step 3. Pick the formula. Ohm's law, V equals IR. Resistance, R equals RAO L by A. Series, R equals R1 plus R2. Parallel, 1 by R equals 1 by R, 1 plus 1 by R2. Power, P equals VI, which is also I squared R or V squared by R. Heat, H equals I squared RT. Step 4. Substitute, then solve. Show every line. Examiners give marks for steps, not just the final number. Skip a step and you leave marks on the table. Step 5. Check the unit. Volts for V, amperes for I, ohms for R, watts for P, joules for H. Wrong unit, wrong answer, even if the number is right. For MCQs, eliminate. 2 options are usually clearly wrong. From the remaining 2, pick by orders of magnitude or by the formula that fits. Never guess randomly when you can rule things out. For 3 and 5 mark questions, structure your answer. Definition, formula, circuit diagram if relevant, substitution, numerical answer with unit, one-line conclusion. That structure is what examiners reward. These are the questions most likely to appear, ranked from years of CBSE papers. 1. Series versus parallel, 6 ohms and 3 ohms. In series, just add 9 ohms. In parallel, product by sum, 18 by 9, which is 2 ohms. Notice the parallel value fell below the smaller resistor. 2. Ohm's law, 0.6 amperes at 3 volts. R equals V by I, which is 5 ohms. At 6 volts, 1.2 amperes. 3. Power and the bill. 100-watt bulb, 10 hours a day, 30 days. Energy equals power times time, 30,000 watt-hours, which is 30 units. 4. A case-based favorite. Copper wires have low resistivity, so little heat is lost. Nichrome has high resistivity and a high melting point, so it makes heat by I squared RT without melting. With 4 amperes at 220 volts, resistance is 55 ohms, and heat in 30 seconds is 26,400 joules. 5. The stretched wire. Double the length at constant volume, and resistance becomes 4 times, not double, because resistance depends on length squared. 6. A voltage current graph is a straight line through 4 volts at 0.5 amperes. R equals V by I, 4 by 0.5, which is 8 ohms. A straight line through the origin means it is ohmic. 7. A combination circuit. 3 ohms and 6 ohms in parallel give 2 ohms. Then add the 2 ohm resistor in series. Total, 4 ohms. Always solve the parallel group first, then add the series part. 8. 2 equal resistors on the same supply. Which gives more heat, series or parallel? Parallel. A lower total resistance gives more power because P equals V squared by R. 9. Why is a fuse a thin wire with a low melting point? On excess current, the heat from I squared RT melts it and breaks the circuit, protecting your appliances. 10. The ammeter connects in series and has very low resistance. The voltmeter connects in parallel and has very high resistance. That way, neither disturbs the current it is measuring. 11. A wire 1 meter long, area 2 times 10 to the minus 7 square meters, of a material with resistivity 10 to the minus 6. R equals ROOL by A, which is 5 ohms. 12. A heater of 50 ohms carries 4 amperes for 2 minutes. Heat equals I squared RT, 16 times 50 times 120 seconds, which is 96,000 joules. Now your turn. 4 quick questions in the CBSE style. Solve each one yourself, then check your answer. This active recall is how it truly sticks. Question 1. A device draws 5 amperes from a 220-volt supply. Find its resistance. R equals V by I, 220 by 5, which is 44 ohms. Question 2. of the same material which has higher resistance, a long, thin wire or a short, thick wire? The long, thin one. Remember, long and thin is high. Question 3. Assertion. Parallel resistance is less than the smallest resistor. Reason. Extra parallel paths reduce the total resistance. Both are true, and the reason correctly explains the assertion. Question 4. A 100-watt bulb runs on 220 volts. Find its resistance. R equals V squared by P, which is 484 ohms. 60-second mind map. Ohm's law, the magic triangle. The graph, slope, is R. Resistance, ROL by A, long and thin. Series adds, parallel drops. Heat and power, I squared RT. Cover the screen and say them all. Then watch this again tomorrow, next week, and the night before the exam. Spaced repetition beats cramming. You have got this. Subscribe, and I'll see you in the next chapter, Magnetic Effects of Current.